My name is Channing Bolt. I am Anna's graduate student and I help her out with things. So I study trace metals. So right now I'm helping her collect trace metal samples, process them, and also deploy equipment.
My name is Mette Kaufman, and I'm here working with the Trace Metals group. We're looking at iron levels in seawater, and we're also looking at nutrients.
Trace metals are essential nutrients to phytoplankton, and we care about trace metals because iron is considered a limiting nutrient. Without enough iron, you're not going to have phytoplankton blooms, at least not to the magnitude that we get here in the Gulf of Alaska.
And the reason that's important is because iron is a nutrient. It affects phytoplankton growth and primary productivity, which is kind of an important part of the marine ecosystem and food web.
So there are three fractions of metals that you can get: dissolved fraction, colloidal, and particulate. They have specific divisions. So particles are anything greater than 0.2 micrometers. Colloids are between 0.2 and 0.02 micrometers. And then truly dissolved is less than 0.02. So Anna measures the dissolved fraction, so she does the 0.2, and then she gives it to me, and I measure the colloidal, so I put it through a 0.02 micrometer filter. So not a whole lot of research has been done looking at the partitioning between metals, so we're trying to address that.
And by sampling vertically through the water, we can actually trace one, where the water came from, and that's over 100 years maybe. It keeps its signature, and it also tells us how long it takes for the water to move. So you hear about the conveyor belt, this deep ocean movement, that we don't really have a good sense of how that's being affected by climate change. By following the trace metals, we can kind of tell what we call residence time, so how long it stays in a certain area, in a certain basin. And that kind of tells us where this water is moving. We collect from the surface all the way down to 700 meters, and then we look at the amount of iron and nutrients through the water column, and then compare that to what the phytoplankton are seeing in the primary productivity.
Phytoplankton solely rely on nutrients and different sources of nutrients to create these blooms. And these blooms are important because, as we know, we're dumping a bunch of carbon dioxide into the ocean. So then when you get a bloom, you remove carbon dioxide from the atmosphere and you sequester it into the ocean. So it's important for different roles of climate change. Phytoplankton are at the base of the food chain, and then you get zooplankton, and then you get the fun stuff like whales and the stuff that people like. But it's the phytoplankton that are really the basis of the oceanic food chain.